Hello everyone, my name is Mario Miranda and I'm the Chief Engineer for this year. I'd like to first start by introducing the team. On the front chassis is myself, Mario Miranda, Osvaldo Gomez. On the rear chassis will be Steven Sagano. And lastly, on roll hoops and impact continuer will be Fermin Sanchez. Our goals for this year are to reduce the weight in the front and the rear chassis without sacrificing rigidity. Also to improve ergonomics. I know this has been mentioned in previous years, but due to driver feedback, we feel this is very important. Also, due to new rules, dimensional rules set forth by SAE, the chassis will have to be redesigned, which will also affect the suspension mounting, which will have to be adjusted. Now, going over the front chassis, we myself, Mario Miranda, and Osvaldo Gomez. At this point, you may be wondering, what exactly is a chassis? A chassis is defined as a physical frame or structure of an automobile, an airplane, a computer, or any multi-component device. It's basically where the suspension, steering, and controls attached to it. Many of the components are attached to the front chassis. It also provides protection for the driver as the driver is enclosed in the front chassis. There's also where the driver takes control of the chassis, so ergonomics are very important. Here's a comparison of the previous years. Prior to 2004, a full space frame was used. In 2004, a hybrid chassis was introduced, which consists of a front space frame and a rear aluminum monocoque. And the previous 4 years, a current front monocoque with a aluminum rear monocoque has been used. The goals for the front chassis this year are to optimize the designs that have been implemented for the past 4 years by decreasing the weight without sacrificing rigidity. Also, to design the chassis to meet the new requirement, the new dimensional rules, and also to improve ergonomics. Many designs were considered. The first one was a space frame. Now, what is a space frame? A space frame can be defined as a truss-like, lightweight, rigid structure constructed from interlocking metallic rods in a geometric manner, as you can see by this image. Now, when considering this, we found some advantages and some disadvantages. The advantages are it's much easier to manufacture, as the materials are much less exotic, talking about steel or aluminum. It's much easier to repair as metal is weldable, and with an optimized design, high rigidity and high strength can be achieved. The disadvantage, however, it will most likely be much heavier. It can be a complicated design and complicated analysis, and requires extra parts to be manufactured, such as the seat and the panels. Next, the composite chassis was considered, more specifically a monocoque. Now, what is a monocoque? A monocoque, can be defined as a motor vehicle in which the body and frame are integrated and absorb all the stresses that are applied to it, meaning that there are no body panels attached to the chassis itself. Now, when considering this, we found some advantages and disadvantages. The advantage is it is much lighter. It has, even though it does not have necessarily the same rigidity and strength as a space frame, it is adequate for applications. And has very good impact resistance, which is very important in case of a crash. However, it is much higher in cost since the composite materials are generally much more exotic and much more expensive. More tooling is required as molds have to be created, and this is the only process of creating this kind of chassis. And the manufacturing cost takes much more time, which is against our goals. But let's look at the materials that we actually consider. S-class carbon or aramid fibers. S-class is a type of S-class is a type of fiberglass. Carbon is also considered. All of these have good properties and not so good properties. S-class is a high tensile strength. It has low impact resistance, but it has lower cost, but it is more sensitive to its environment. Carbon, on the other hand, has a high strength, high stiffness, but it is much higher in cost. Aramid, which is commonly known as Kevlar, has very high tensile strength, low density, but it also is very susceptible to its environment, such as UV radiation. Due to its high stiffness and high strength, we will continue to use carbon fiber as a material of choice for our composite chassis. Now, to actually go about manufacturing composite monocoque, generally 2 molds are created, a male and female mold, the male being the master mold. The female mold is then created using this master mold, and then a pre-preg or wet layout is actually used for creating the chassis. The male plug with a master mold is either handmade or CNC routing. We will continue to be using a CNC routing because it creates better accuracy and is done much faster. We have contacts which make it easier and faster for us to make this mold. The female mold can be then created either using carbon fiber or fiberglass. In previous years, fiberglass and carbon fiber have been used. Fiberglass is much less expensive, but it requires bracing and is not as rigid and durable. Carbon fiber is much more expensive as it is a more exotic material, but it does not require any extra support and is very durable. Now the actual manufacturing methods that I mentioned are pre-impregnated or heat wet layup carbon fiber. The main important thing to consider is the resin content. With a pre-impregnated carbon fiber, the resin content is known. And with a wet layup, it does not. It has to be manually regulated. This can increase the final weight of the chassis tremendously. Because of this, we will continue using pre-impregnated carbon fiber. Next are core. Core is a material sandwich panels created with material between layers of carbon fiber. The different kinds of core that we consider are aluminum and Nomex. Aluminum has been proven to be much easier to work with, has a high shear strength, but it is heavier than Nomex. Nomex, on the other hand, is lighter weight, but it is much harder to work with, and it's hard to contour to our design. Because of the easiness of working with, we'll continue to use aluminum core. And now to continue with the front chassis will be as following elements.
I'll actually be speaking about the chassis assembly and the ways that we considered fastening both halves together. The first type was using mechanical fasteners, which actually don't require any additional surface preparation, but unfortunately do require that we drill into the chassis, which it does increase the stress points in the chassis. Furthermore, we also have to use hardware, which also increases the weight in the chassis. The second type is through an epoxy bond. This actually gives us a really good strength to weight ratio and minimal weight gain, and it avoids any kind of hardware whatsoever. Next, we need to take into consideration the ways of mating both halves together. The first consideration was a lap joint. This actually gives us a very large distribution of stresses, but unfortunately it does require more tooling, and it does give us an overlap, and it is more susceptible to bending stresses. The second type that we considered was the tongue and groove. This actually doesn't consider any special tooling. It takes advantage of the layered structure. It does give us a flush finish, and furthermore, we will probably reinforce it with carbon fiber tape. Next, we need to consider inserts. The inserts are actually really good to use with carbon fiber panels because they protect the core from crushing, and they provide suspension pickup points at any non-crucial location or pickup point. The types of inserts that we considered were two. The first type would be the press fit type. This actually uses a two-piece adhesive bond, and it is not a flush finish. The second type that we actually considered does give us that flush finish that we desire, and since it uses the epoxy for structural support, it also does give us a very high tear out and torque out strength. In conclusion, I wanted to let you guys know that we will probably be using the pre-preg carbon fiber, aluminum core, the epoxies for mating, the tongue and groove joint, and finally the potted inserts. Next, I will turn the floor over to Steven Sagano.